Moor is a powerful library for using an SQLite database from your Flutter apps by writing pure Dart code. In the first part of this series, we've only touched the basics of this package. Let's now take a look at some of the more advanced queries and also how to keep your code clean by separating it into data access objects. We're gonna take a look at the advanced queries both in the Fluent syntax and also on custom SQL queries. Hello, welcome to ResoCoder. In this part we're going to add the functionality to this app, and be sure to check out the previous part of this series by clicking on the card in the corner, and we will add the functionality to filter tasks by their completed status. So if we complete some more tasks and show completed only the completed ones will be shown. This is the main thing which we are gonna be doing in this part, and we will write this 3 times. First, we are gonna write this in the Fluent syntax, then in a type-safe generated SQL, and then in a non-type-safe manner by using the so-called custom SQL Strings. And be sure to check out the written tutorial from the link in the video description on resocoder.com, where you can also find all of the code written in this video, in-depth explanation which you can read at your own pace, and also links to the documentation. There is really a lot to learn, so let's get right to it. First, let's go to pubspec.yaml and update Moor Flutter and also Moor to the version 1.5.0. This is the newest version and it comes with some sweet stuff. For example, the generated queries, which are type safe if you write custom SQL. Prior to that, you could not write type safe custom SQL, but with version 1.5.0, that's totally possible. So let's update Moor Flutter to be 1.5.0. Also, Moor Generator will be 1.5.0. And in addition to this, we will also specify the core Moor package directly. So we're going to use the plugin PubSpec Assist. If you want to learn more about which extensions I use on VS Code, check out the video from the card in the corner. And using PubSpec Assist, we'll search for Moor. And let's add Moor over here. It's at version 1.5.1. Once we save that, we will use version 1.5 or 1.5.1 respectively of Moor. This introduced some breaking changes though, so let's take a look at the Moor database class. We see that we have some errors saying that the argument type task cannot be assigned to the parameter type insertable task, and also here inside the generated code we have a bunch of errors down here. So what's going on? Well, to fix this, together with updating the package, we also have to rebuild the Moor database so that the new things, the new code added to the version 1.5.0 will be reflected in the generated code of our Moor database file. So let's open up the console and let's simply run our good old trusted command, flutter packages pub run build runner watch. And with this, all of the errors will be fixed because the newly generated code will use the new version of Moor. Version 1.5.0 added something called update companions, which are generated companions to the data classes. For example, this task data class. And whenever we want to insert, update, or delete a task, we can either specify the data class directly, as we are doing currently, or we can also use its update companion. This is all because of nullable fields and some problems with it. Now all of the fields in a data class are marked with the required annotation right here in the generated class, and that's why we have some warnings in the new task input, because over there we are instantiating a new task and we have not specified all of the required parameters for this constructor. We are gonna come back to this issue toward the end of this part. Let's now focus on data access objects. All of the code for queries currently lives inside the AppDatabase class itself, right here. And at the moment, that's perfectly fine because we are dealing only with tasks. But we have to think into the future, because once we would start adding comments, habits, and who knows what into this app, placing all of the queries, even for comments and habits and everything else, inside a single class AppDatabase would create a mess. To separate the queries dealing with tasks, and in the future with all of the other classes, we can use data access objects, otherwise known as DAOs, which is an abbreviation. Functionality of the queries will remain unchanged, but they will only be moved into a separate, different place. We will create the DAO below the AppDatabase class. So let's create class. It will be called TaskDAO, and every DAO has to extend a database accessor, because after all it accesses database. So extends database accessor, and we need to specify the type of the database which is being accessed. So in our case, that's AppDatabase from above. And then also TaskDAO will have some code generated for it, similar to how there is a generated class for AppDatabase. We also want to specify the generated class for TaskDAO. But the generated code will not actually be a class, it will be a mixin. And to use mixins in Dart, we have to use the with keyword, and its name will be $$ TaskDAO mixin. Also, we're going to annotate this class with @useDAO, which is similar to @useMoor for the AppDatabase class. And inside here, we are again going to say that the tables which this DAO can access are tasks. And then also, we have to add this DAO to the AppDatabase's annotation, where we'll specify that DAOs is equal to only TaskDAO. Let's now save this file so that the code can be generated by the Moor generator. Once that's done, we can see that we have an error on the TaskDAO. That's because we have to add a constructor. So let's add it right now. A constructor for DAO has to take in the database instance. And we're actually going to store the database instance inside a class field, which will be final AppDatabase, and we're going to call it simply DB. Then we're going to use this field inside the TaskDAO's constructor, so this.db, and also call the super constructor with this DB instance. We are not going to instantiate DAOs directly. They're instead going to be instantiated by the AppDatabase class. And what we can do now is what we've tried to do from the very beginning of this part. That is to cut out all of the queries from the AppDatabase class and instead paste them into the TaskDAO, and their functionality will not change at all. Obviously, we've just broken our UI code, which currently works with the AppDatabase class directly. We're going to fix it later. Before we write any more advanced Fluent or even custom SQL queries, let's make the already present simple queries leverage the power of the new update companions from the version 1.5.0 and upwards of the Moor library. Currently, we are inserting, updating, and deleting tasks, and these methods take in a task data class. But we should allow these methods to also take in the task update companion, because that's just a good practice since 1.5.0. And obviously we're gonna get to what update companion actually means precisely later in this part. For now, let's just say that these three methods, instead of a task, should take in an insertable of task. So let's now copy this and make it happen for all of the three methods here. And insertable abstract class, I think, yeah, is implemented by both the data classes and also their update companions. Until now, we've been getting all of the tasks out of the database, either just one time or we've been watching them and returning a stream. But what about ordering them by due date? And what if we only want to see the completed tasks? Well, with Moor, that's really simple. We can use the Moor's Fluent syntax and write everything in Dart. So let's change the implementation of watch all tasks to order tasks primarily by due date and then also secondarily by their alphabetical order. Also, we will add a watch completed tasks method, which in addition to ordering will also return only the completed tasks. Watch all tasks will no longer be an expression-bodied method because it's gonna get really messy this way. So let's add regular curly braces to this method and let's separate it from the rest of the code, and now we will begin writing. So we want to return select, and from the tasks table as before. And on this select, now we want to use the order by statement. So we can call order by. The problem now is that order by returns void. So if we wanted to call watch on this, we would not be able to do that. If we do not want to assign the return value of order by to this whole call chain, we can use the cascading operator. And by doing this, we can chain more statements after order by. So for example, where or limit or anything like that. And to actually watch this query, which is currently not possible, we have to wrap this whole select statement inside parentheses. And now we'll be able to call watch on it. That's just how it is with these cascading operators. You have to use parentheses afterwards to wrap the whole statement beginning from select till the end. And now let's implement order by. The signature of this method is that it takes in a list of anonymous functions here, which return an ordering term. So let's pass in a list here, and inside this list we will have all of the sorting functions. They take in an instance of a table class for the tasks table, so we're going to call it T, and then from here we want to return an ordering term, and this ordering term will have an expression in it. And we want to primarily sort by due date. So we are simply going to get the due date out of the table. And then, because we want to have the greatest date sorted to be on the top of the list, we want to also specify the mode to be ordering mode descending. So we want to sort it by due date descendingly. So ordering mode.desc for descending. But we don't want to end it there because we also want to sort secondarily. So let's actually copy this below by using Shift Alt and down arrow in VS Code, and we're going to change the expression to be t.name. So name sorting, alphabetical. And also we want to sort it ascendingly, so we can delete it actually because ascending sorting is the one which is applied by default. We don't want to only watch all tasks though, we also want to have a method for watching only the completed tasks. So let's actually copy watch all tasks and paste it below. We are going to change it to say watch completed tasks. And inside it, in addition to saying order by the due date and the name, we are going to chain another statement after order by, and we will want to use where. And we will say where on the table there is the completed field from the table equal true. So if completed is true, it's going to be added to the data returned by this select query. So now when we save that, we have successfully implemented even watch completed tasks, and you can get all of this code and also learn from the written tutorial from the link in the video description. For what we are trying to do, it's perfectly possible to use only the Fluent syntax. But sometimes Moor's Fluent syntax just doesn't cut it. Even though with each update the functionality of this package increases quite a lot, not everything is supported yet. If something like that happens, you can always fall back on writing pure SQL. Starting with Moor 1.5.0, it supports type-safe generation. While we could do all kinds of craziness writing custom queries, we are going to simply duplicate the implementation of watch completed tasks. So we're going to have 3 methods for watching completed tasks. One will be this one in Fluent syntax, and then other 2 will be either type-safe SQL or non-type-safe SQL. To generate type-safe methods from SQL, we will specify it inside the DAO annotation. You can also specify it inside the use Moor annotation if you are placing your queries directly inside the AppDatabase class. We are, however, using DAO, so let's specify it over in the use DAO annotation. So let's specify queries, which will be a map. And inside this map, we are going to specify the name of the method which will be generated. So let's say completed tasks generated. This will generate actually 2 implementations. One will simply call get to get it only one time, and another implementation will call watch to return a stream. Now let's specify the SQL string which will be applied inside these methods. We want to duplicate the functionality of the Fluent syntax, so we want to select all tasks which are completed and also then order them descendingly by due date and ascendingly by their name. So let's go over here and we'll write some pure SQL strings. So we want to select asterisk, so everything from tasks table. So something like that, it's called tasks, even in the real database, where completed field is equal to 1. Why 1? Well, booleans are not really supported directly. They're integers which can be either 0 or 1, and 1 simply means true. We could also use a variable over here and not specify this value in line, but I think that the inline specification of this 1 value of this true is perfectly fine. And then we want to order by, and we want to order by due date, and we have to use underscores for spaces. This will be ordered descendingly, so DESC, and then name. We mustn't forget to specify the semicolon at the end. And now when we save that, because we've used the watch command in the terminal, it's been automatically generated. So now when we go to Moor database generated file and look into the task DAO, which is all the way down, we can see that inside the task DAO mixin, we now have something more generated. That's completed tasks generated, which returns only a future of the tasks which are completed. And then we also have watch completed tasks generated function, which returns a stream. Using source generation for creating custom SQL queries is amazing because we do not have to write any boilerplate, and in addition to that, it's also type safe because we are not dealing with dynamic data. However, source generation currently supports most, but not all statements and not all kinds of craziness. So if you do not mind dealing with dynamic data, you can also write a custom method, which will be all done by you and not generated by the Moor generator. So we're going to create another method now directly inside Moor database class below watch completed tasks. And we're going to call it watch completed tasks custom. And to create custom queries which return a stream, we are going to return from here custom select stream, which will take in the SQL query, which we're going to actually copy from the generated one because it's exactly the same. And also so that this stream knows when to emit new values, which should happen whenever something inside the tasks table is updated. We also have to provide reads from argument, which is a set containing some tables, and in our case this only will contain the tasks table. So whenever the tables inside the reads from set are updated, this custom select stream will run again and it will emit new values, which is precisely what we want from a stream. And now on this stream we want to map all rows of this query. So this map is called on the stream and it will run every single time that new values are emitted. And inside this map rows, we want to return rows, which are the rows returned by this query, dot map again, because we cannot deal with rows which contain raw data. In our app, we actually want to convert these rows into some meaningful values which are contained inside the tasks data class. So we want to map rows, which will grant us single row, and every single row inside this map function will be converted to a task, and every data class provides a from data method which takes in the row data. So we want to specify row.data, and this data is dynamic, string dynamic, and also specify the database instance, which is called DB in this DAO class. And with that done, we just want to convert it to list. So that to list mapping returns an iterable, but we do not want to have an iterable. We want to have a list because the stream should contain a list. All right, so we have three versions of the same functionality of watching completed tasks. We have generated type safe code, then Fluent syntax, and then non-type safe custom select stream code. Let's now change the UI so that it has this completed only switch inside the app bar, and also let's use the update companion. First, however, we need to start in main.dart, where we are no longer going to provide an AppDatabase class, but instead it's DAO, which is called task DAO. Inside the home page, and I'm going to go fast through this, you can always get the code from the link in the video description, which is going to take you to resocoder.com. In here, we'll want to turn everything from AppDatabase to the task DAO. So build list item will no longer take an app database, but instead a task DAO, and it will delete tasks and update tasks on the DAO. As we scroll up, we can see that build task list also has some problems with the app database. That's because the provider no longer provides an app database, but instead a task DAO. So if we change this so that the provider will grant us a task DAO, and also the stream builder will call DAO watch all tasks, will be good to go regarding build task list. However, that's not all we want to do here, because we also want to add the switch to the app bar. This switch will need to operate with some value, which it will actually switch to true and to false, and that will be a Boolean show completed. So let's add it to the top of the state class. We are going to build the layout for this completed only switch inside a separate function, which will be called build completed only switch, which will return a row containing a text and then a switch, which will operate on show completed. And whenever this switch is tapped, we'll simply change the value of show completed to the new value coming from the switch. And then finally, we want to make sure that this switch is displayed inside the app bar. So we'll specify actions and set it equal to build completed only switch. And once we have this switch, let's use the value of show completed inside the build task list, where we'll differentiate between if we want to get all tasks or if we want to get only the completed tasks, or more properly, if we want to watch them. So we will say show completed and use the ternary operator. And if we want to show only completed, we will call DAO dot watch completed tasks. Otherwise, we will call watch all tasks. And over here, feel free to experiment with the custom and also generated methods, because they will do precisely the same thing. Things will get really interesting inside the new task input widget, because it's here where we want to use the new update companion for the task data class. In here, we are currently instantiating the data class directly, but we omit two fields, ID and completed. And that's actually what the Dart compiler is complaining about, because now these two parameters of the constructor are marked as required. But our reason for omitting ID and completed is perfectly reasonable. That's because if we go ahead and take a look at the table definition, we can see that ID is an auto-incrementing integer, and then bool column called completed has a default value set to false. So we should be able to omit these values because they will be automatically populated by the Moor library. The reason why the new Moor version, starting from 1.5.0, decided to mark these parameters as required in data classes is that omitting parameters will set them to be null. And nulls in data classes should be reserved for real null values. For example, due date can be set to null because it's nullable. Inside the table definition, it's marked as nullable, so only this date should be able to be really null. So hypothetically, if we were to remove due date from here, the Dart compiler would not complain about the due date being removed, because that's nullable. That's perfectly fine to omit it from the data class instantiation. What we are trying to do with omitting ID and completed is to just set them to be non-initialized, so that then the Moor library can take over the process and initialize them for us, either by incrementing the ID value or by setting completed to be false by default. Instead of a null value, non-initialized fields in a class should be now set to an absent value, and this can be done using the update companion. It's really simple. All we have to do is to change this task to say task companion, which is also a generated class, or actually tasks companion in plural, and then just set name to be equal to input name, but we have to wrap this value inside a value. So just wrap it here and also import it from Moor Flutter, and then also wrap new task date in a value. And if we take a look by hitting F12 on this task companion, we can see that all of the omitted values in the constructor will be set to value.absent and not to null. If we now go back, all we have to change now is that the provider will no longer get AppDatabase, but instead task DAO. And it will store it inside DAO. And now let's call insert task on the DAO. And let's now run this app. And here we go. We have 2 tasks, but just to test if inserting a new task using the tasks companion works, let's create another task. We'll also set a date on it to be in the June, maybe June the 12th. So something like that. It will say my task, and let's add it. So it's properly sorted only after the new task because its date is prior to the 30th of June 2019. It's the 12th of June 2019. And then if we add a task without any kind of a date, it will be sorted after another task. But if we say AAA and add it, it will be actually sorted before another task because AA is before AN, right? And now we can test this completed only switch. It seems to be working. Yep. And let's actually go to the home page and test every single implementation of watch completed tasks. We are currently using the one with the Fluent syntax, but we can change it to the non-type safe custom implementation. So let's check it out. It works just the same. And also, if we change it to the generated one, it will surely work the same too. So yeah, it works precisely the same. So we have successfully implemented this function 3 times, twice in custom SQL, once with the type safe thing, once non-type safe, and once in the Fluent syntax. In the next part of this Moor series, you will learn how to perform table joins, which is a very important operation on relational databases. So you definitely don't want to miss that part. So subscribe to this channel and also hit the bell button to join the notification squad so that you will be notified about every new tutorial that I upload. Because here on ResoCoder, I am determined to provide you with the best app development resources and tutorials out there. If this video helped you with writing more advanced queries in Moor, give it a like and also share it with other developers who will surely benefit from it too. Follow me on Instagram if you want to get the most up-to-date information of what I am up to, what kinds of tutorials I am creating for you. Leave a comment if you have anything to say, and see you in the next video.